to be alive and to participate in this lecture. As you go through, we pray that you lead us through all the necessary information that the student need to have. You give me the grace to give them. Bless you in Jesus' name. Amen. All right. So we are going to continue from where we stopped the other time. Still, this one I decided that we have the virtual class because it's mainly reading. We've not reached the portion where we'll be doing the calculations, and that is the stage where we'll start our physical class. So the other time we ended with some steps to follow when carrying out a design, and today we are going to continue and look further into that. So the title we are on now is the system design cycle, and any design or any system that is designed have to go through a certain procedure. All right, and for solving any design problem, there are some general procedure that must be followed in order to have a good design, and this procedure is known as the system design cycle. The various activities within the cycle has been codified to Asimov, has been codified by Asimov, considered to be the father of system design, and the activities of that system design is shown in the figure 1. Figure 1, we can see figure 1 is down there. Let me go to figure 1. So this is figure 1, and in figure 1 we see a flow chart showing the design cycle. Okay, so first we have recognition of the need. So there has to be a need, and after that we have the specification and requirement. So specification and requirements, then feasibility study, creative design synthesis, and we also have a preliminary design and analysis. Then we have detailed design, prototype building and testing, and then we have design for production, and then finally the release of the product. And at certain stages you will have to go back and check some. For instance, at the feasibility study level, at that point, if at that point you are not, the information that you're able to acquire from the market after doing the feasibility study, realize that will not be helpful to go on with the design. You have to go back and look at the specification and requirement, and then we can also see a link between the preliminary design and analysis to specification and requirement. All right, then also the between design detail, the detailed design, and then also the specification and requirement, which means that there's some interrelation between the various components of the design procedure. Then between preliminary design and analysis, and then the prototype building and and testing, we also see some relation where when you get to prototype building and you realize that after building the prototype and testing it is not performing as you have obtained from the preliminary design and analysis, you would have to go back and do some maybe modification to your design. Then you continue again. And we also have the product release. Okay, when the product comes out finally. Between that and then the preliminary design and analysis, we also see a link there that after the product has been released, at times maybe there have to be some information or feedback the market. Hello, can you hear me? Can you hear me?
Yes, sir, we can hear you.
We can hear you.
All right. So after the product has been released and is in the market, there are times when those who have released the product will have to get some feedback, okay, from the market, and that shows how customers are using the product, how the product performs, and they need to get some reviews from the customers, and those reviews will inform the designer to either modify the design, make it better, and or it's okay. All right. So that back and forth have to be done until we have what is that? Let's mute your microphone if you are. Okay, so that back and forth movement until a perfect product is released to the market. We are going to look at the various items that I've mentioned here from the flow chart. So the first one is recognition of a need. All right. I think I mentioned the other time that before anything is done, you are designing something. There have to be a problem or a need which you intend to produce that design to satisfy or to solve. And that is the first stage in the designing process, where the need for a particular design or product is brought to the notice or knowledge of the engineer through any of the following ways: by holding discussion with management to arrive at something which, when designed and put into use, can improve the production system of an organization. A customer approaching the engineer with a specific problem at hand. So here, for instance, somebody approaches you as an engineer. I find it difficult, say, to work. The person says that is a problem. So you, as the engineer, you will have to now sit back, think through, and see what you can do to help that person to work or to assist that person to work. All right. So first of all, you have a need, then the design will become necessary. Then we have the problem arising from the production line of a company or an industry. There are times maybe in the company, all right, or in the production line of a company or an industry, there could be some problem that may occur. And let's assume that you are working in that company as an engineer working there, and this problem happened. How do you solve it? All right. So engineers like mechanical engineers should be able to be creative, to imagine, to be able to come up with something to solve that problem. Okay. It could be a failure of maybe some machine element, or in the industry, there's something that the company want to achieve. So as an engineer, Do they have to um, look for that thing outside somewhere, import it to be used by the industry, or can something be done and manufactured locally to solve that problem? So you being the engineer, when that problem is identified, then becomes necessary for something to be done to solve that problem. Okay. Yeah, just a minute. Um, Hello. Okay, so let's continue. Uh, and also focusing on the need to design something which is highly marketable and beneficial to many users. Okay. So, for instance, the design of the say the smartphone or a phone, let's put it that way, came in to satisfy the need of people, because maybe before, somebody who wants to speak to a friend, parent, or someone somewhere, they have to travel. All right. Or if the person cannot go, the person have to write a letter and post the letter, and that may take maybe days, weeks, or months before arriving at that person's place. That is a problem. So what do you do? And this is a need that is there, it's common to many people. So the engineer sits down and see, what do I do to be able to solve this problem? And when that problem is solved, it satisfies the need of many people and becomes marketable and beneficial to those people who make use of that product. Then we also have making consideration of previous designs. So here we are looking at designs which are already there. There were previous ones, but it could be that those designs may be having problems. All right, they may not be working efficient enough, and because of that, there is the need for you to maybe modify, do some improvement on them to make them better. Okay, so all these are various sources where you can recognize a need and then come in to assist. Then the recognition of the need and defining the need often constitutes a creative act, because the need may be only a vague discontent, a sense that something is not right. Recognition is usually triggered by particular adverse circumstances, right? The need may be existing or may not yet exist, but the evidence may be existing that the need is latent. That is, the need can be evoked when economic means for its satisfaction become available. Okay, so there may be some need, but economically it will not make sense. You may spend a lot of money into doing a research to solve a particular problem, which that problem at the end may not be accepted by the society or may not be useful to many people. At the end, yes, you have tried to do something, but the effect of it will be minimal on the society. All right, then the next one is specification and requirements. A specification is a description of the problem to be solved. So when you have identified the problem, one, you need to be able to describe the problem in detail. The problem to be solved, you need to be able to describe it in detail, showing exactly what the design must achieve. So you should be able to specify the objective. What is the aim? What do you want to achieve with that particular design? While taking into account the design limitations, showing which will affect the final solution. Okay, At this stage, the engineer or the designer finds out specifically how the machine should be designed so as to satisfy the need with regard to specific function of the machine. The specification may include dimension, dimensions of the space, the object, with the dimension of the space the object will occupy, the cost, the input and output quantities, the characteristics, the number to be manufactured, like how many um, um, items that ought to be manufactured. All right. So when we look at all these things, that gives you the design specification that what you are designing should fit within this space and should not go beyond that. Are we okay? So you define those things very well at this stage. And then the expected life, the minimum and maximum range, the operating temperature, the reliability and weight limitations, and any limits on the design are called any limits on the design that are called constraints. You need to um, be able to specify all these things clearly. All right, there are some designs, for instance, when you want to design a machine that will fly like an aeroplane, we know that the aeroplane should be able to maintain buoyancy, to be able to fly, and we should be able to, as much as possible, reduce the weight of the aircraft so that we can carry more payload, because the lighter the aircraft will be, the more load that we can have, assuming that the aircraft has enough power to be able to fly those loads. So in that case, we need to be able to define the weight limitations, that the object that we are designing should not the weight of it should not go beyond this value. Okay. And then the size of it. And we know that anything that we have, any machine that we have, they all have lifespan. Whatever the object is, at some point that object will bring its service to an end. And because of that, we should be able to have a clear view of, or an overview of, the life that we should expect from that device which we are designing. Okay. And there are times, maybe in some machines, we have certain parts of it that are prone to failure at some point. Okay. So in design, when we know that this is the life of that object, we put it in the design such that when somebody is using that component, the person know that if I've used it for 1,000 hours, I should replace it. If not, it will fail when I'm not expecting it. Okay, so after some hours, it's said that that machine or that particular part has exceeded, or it has reached its maximum working life, and it has to be replaced in order to for the system to continue functioning correctly. But the engineer also takes into consideration the form of energy the machine is going to use, the type of engineering material suitable, considering the environmental factors associated with the site of installation. All these things will need to be a feasibility study. Once the problem's need has been established and the specification have been prepared, accepted and submitted, the feasibility study is done. The purpose is to check the possibility of success or failure of the proposed project, both from technical, economic standpoint of view. Okay, so at the feasibility study level, we are looking at it. Will this product succeed? For instance, if we are designing a product that you want to sell to the market, okay, we expect that when this product comes out, people will accept the product, they will patronize it, and you are going to sell it to get the needed benefit that you want. So the feasibility study, along this stage, the designer does the following. Okay, so at that point, the designer does the following. And the first is market survey to find out the availability of material that can be used to construct the project based on the specification and requirement of the project. There have to be availability of materials or resources, okay? Because you may have a very good idea, but if that product you have cannot be manufactured, then it will not be of any use to anyone. Because you may have a good design on paper and all that, but the system or the machinery needed, the human expertise needed to be able to manufacture that product are not there. You may not have the skilled people who can help to manufacture them. Then that product cannot be done. Or maybe the material that you will need for such are not available. Then the work cannot be accomplished. So you need to first of all do a survey, market survey, find out the availability of material that can be used to construct the project. Are they there? And based on the specifications or the requirement of the project, take decisions as to whether to manufacture some components locally or obtain them from a component manufacturer. Right, that one you have to take that decision. There are certain machine elements that you may not have the facilities to produce them by yourself, and therefore if you don't have, you should be able to identify a manufacturer who maybe you could send the specification of that particular machine part or element to. That person will, or that manufacturer will do it for you. Then you bring it, add it to your design. And there are some to which you may be able to do them locally. Maybe fabrication, welding of certain parts and all that could be done locally, maybe in the local workshop. That one, you know that can be accomplished. Okay, so those ones which you may have to obtain them, make arrangement for that. Those one which you may be able to do those things locally. That one too, you need to take all those decisions. And the relative cost of getting each raw material, items, components, etc. for the project. So here too, you need to be able to determine
I have a high
cost. Find out, do you have enough funds to be able to go ahead and complete it? Because you may have a very good idea, but if the funds to do it are not there, then you see that your work cannot be accomplished. Okay, so you need to determine the cost of getting each raw material, the item, the component that you need to have. You need to be able to determine that. And then selecting the best effective and most economical feasible method out of the lot considered. All right, so you should be able to also select the best, the effective, and the economical one. Okay, because one aspect as we are designing, we should ensure that our product that comes out is at as cheap as possible. Okay, in terms of the production cost, the cost that goes into the production should be as cheap as possible. All right, but if it is so expensive, at the end you see that the end product when it's going to the market is also going to be very expensive, and customers may not be able to afford it. And if you also make it the production cost so cheap, if you're able to reduce the production cost, what happens is that you're able to also increase your profit margin when you sell that product. Okay, and also you need to find out if any natural law is being defied, if any natural law is being defied, okay, you should be able to find out through the feasibility study period. Then we have creative design synthesis. This phase is the most challenging and interesting part of design. Here, the designer can act as engineer, inventor, and even an artist all in one, because he is now called upon to create. So you are creating, you are making something new, okay, bringing out something, and mostly it will come from your mind. Okay, this stage is where the designer uses his own creativity, his knowledge, his skills, his innate potentials to make sketchy designs and diagrams of the various components of the machine prior to preliminary designs of the project. So before you come to preliminary designs of the project, where maybe you have to do some drawings and all that, you first need to have that mind. You should be able to have that imagination, okay, in your mind. So you have the concept in your mind, you make some sketches of the picture of that product you want to have in your mind. So you are like an artist. The the beauty of the thing, the aesthetics of the thing, everything has to come from the designer or the engineer or the inventor, the one who is doing the work. You may do something, okay, and at the end you'll see that it will work. For instance, if uh, let's say we are designing a chair to sit on, something like a chair, okay, to sit on. Well, it's something that you just sit on. As an engineer, if you design it, so long as somebody can sit and it will carry the person, well, you have done something. But you agree with me that if you go to the market and you want to buy something like just a chair, you are not only considering whether you can sit on this, but you're also considering the beauty of that thing, okay, the aesthetics of it, how it looks like, all right, and then how comfortable it will be when you sit on it. Okay, so we put all these things in consideration. So the engineer or the designer who is doing it have to ensure that it's able to meet all the needs that the customer may have. Okay, then preliminary design and analysis. After the process of creativity design is complete, there will be one or more possible designs that satisfy the given set of specification and requirements. It becomes necessary to decide which of the solutions to choose for the preliminary design and development stage. So here the designer, here the designs and sketches obtained from the previous stage, all right, are scientifically analyzed in this stage. The designer considers the following. One, he considered the application of standard engineering calculations. So here you have to do some engineering calculations. You have done things on stress analysis. I think you did basic maths, resolution of forces and all that. So before that thing is done, before you're able to build a thing, you should be able to ensure that you have some good information about what is going to be used for, what kind of force that will be passing or that is going to carry or is going to bear. If you have that in mind, you'll be able to determine the size of the various components of that machine that you are designing, so that when those stresses are induced in them, they will not fail prematurely. Okay, and you use those. There are some formulas that we use, engineering formulas that we use to determine, do those calculations, stresses, strains, deflections in the members, and other things that all have to be done. Suitability of the selected engineering material for various parts based on the forces that will act on those parts. So we should be able to determine which material should be used for what purpose, and that will be dependent on the forces that will be acting on them. All right, so there are some material which may not work well for certain type of forces or certain by the way that certain forces will be acting on it, it will fail prematurely. If it's going to be used if it's going to be used in an area where there will be repetitive uh, 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 cyclic loading, like there will be fatigue loading of the member, and you choose a member that is very brittle, you see that it will fail within a short time. It will just break apart. All right, so you consider the material to be used based on the the application of that particular part. If you are taking the machine, which is a system, a big thing, it consists of different parts, and each part will be having its own function. So based on the function of that particular part or a particular part, you select a material to be best suitable for that application. Preliminary design data, construction details, and projected characteristics. All these are determined under the preliminary design and analysis. Okay, then we have detailed design, or we call it this detailed engineering drawing. So in this case, it's like you are now going to come up with your design for manufacture. So here, the engineer or the designer may not necessarily be the person who is going to manufacture it, okay? We have artisans who are skilled in using machine tools like the lathe machine, milling machine to do all that. But the one who is doing the designing, the calculation and all that may not necessarily know how to use those machines, okay, to be able to manufacture the various parts. We have people who are um, well skilled in casting, foundry work, okay? So if you want to do foundry, do casting or whatever, they are there and they can do it. So you as the engineer, you need to ensure that you give proper information to these people to do the work. And that is where the detail engineering drawing comes in. So here, mainly you are going to provide detailed drawing and dimensioning, proper dimensioning of the various parts of the machine that you are developing. So when you have that, any manufacturer that you give to, by looking at the drawings that you've presented, they'll be able to manufacture or produce that part even without your presence there to direct them and tell them that do this or do that. By looking at the drawing, they'll be able to do it. Okay. And similar, like when somebody is building a house, you don't just go and then be digging the ground to build. And those, we have architects who do drawings, and most of them don't even know how to do mason work. They don't know how to do it, but they can do good drawings. And when they do the drawings, they give to those masons who uh, do the work. And they on ground, they know how to dig, how to mix the mortar, and then join block to block and do this and do that. And so long as there is a good design that has been done, they are able to produce good work. So long as they have uh, the skills to do it. Okay. All right. So we go to the next one, the prototype building and testing. After completing all the details, the sub-assemblies and assembly drawings, including the material and part list, the completed design is sent to the prototype or model shop for fabrication. So this is where the model shop or the manufacturing process is carried out. At this juncture, the parts are fabricated. So they make the parts, the various parts are produced, and commercial components are purchased. So they are parts which you can purchase them. You may not fabricate them in the local workshop. For instance, if you want to use something like a bearing, you may not be able to easily manufacture a bearing, but we have companies that are specialized in that, and that is what they do. All you need to do is to have the type of bearing you want, the size, then you just get it purchased. You buy it, then you use it in your design. The first example that is design model. The first example form, which other forms may be developed, is built and tested as to the proof of the operating characteristics of components, and also the proof of soundness of the complete entity. Okay, so you don't just rush into mass production. All right, you don't rush into mass production. First of all, one have to be made, which we call the prototype, and that prototype has to be tested. All right, so it's tested to ensure that it will be able to function as expected. If the prototype is tested and it reveals that there are certain flaws there or whatever, then maybe you have to go back and check your design again. Okay, generally it's used to show what the machine will really look like in full scale. When it is in full scale operation, how will it look like? The prototype will demonstrate that. And also the testing of the prototype helps to establish several factors, which include first, the acceptable producing acceptable performance. Is it able to perform to satisfaction? Okay, it reveals some flaws within the design. If there are certain flaws in the design, when the prototype is built, you are able to tell that very clearly. And then verifying design hypothesis, is able to verify the hypothesis, your design procedure, what you have done to be able to develop that, and the idea you were having in mind. This will verify that truly what you have done is correct. And if not, it will also show developing improved design concept. Okay, and it will help you to improve. It will help to develop improved design concepts. As you have done that design, the procedure you have gone through to do it, if it doesn't work properly, you've been able to identify, you have a better design. As you go to the next stage or before you continue, you ensure that whatever have to be done are done. All anomalies that have to be corrected are corrected. Exposing difficulties overlooked in the theoretical design. Exposing difficulties overlooked in the theoretical design. Okay, otherwise when we are doing certain uh, design, maybe along the theoretical design where you are doing some calculations, you may encounter some problems. At times designers may just overlook such things. Okay, they will somehow you may cut corners to be able to get some desirable results, but when it comes to the real thing and it's working, then you will see that no, this thing should be something that you should have considered seriously, not just uh, overlook it and let it go into the design. Because as you overlook some of those things, they will affect you, the final product. And then also increasing the validity of results. Okay, so it increases the validity of the result that you produce. Any question up to this point before we continue? Any question? Uh, all right, let's continue. So design for production. All right, or production from design for production. Depending on the satisfactory result during the testing of the prototype, the final permission for production is granted. This is where the manufacturing processes and various techniques of production are employed to carry out the design. Okay, and then finally, the release of the product or the release of the product. After going through the production process successfully, the product is then released for testing in a limited market. So we limit, okay, in a limited market, it's released for testing. It is only when management is satisfied that all problems associated with the product are solved that the product is finally released to the wider market. Okay. You need to know that in the system design cycle, any drawback at any stage can be easily corrected by following each feedback loop. Okay, so you follow the feedback loop to the appropriate previous stage. So the feedback, you need to be able to connect if there is a problem. Where is the problem coming from? Okay, so if for instance you have reached the product release stage, and maybe after the product is released to the market, maybe to that limited market, there are certain things that shows that it's not performing as required, then we have to come back to our preliminary design and analysis stage, or we need to come to the detailed design process, the place where we have done the detailed design. There are times when there could be some mistakes that were generated along the way, and that will affect the outcome of the cycle. And when that is determined, we need to go back and then start from the beginning, from the point where the mistake was made, for things to be corrected. Then the process can continue. Any question? Uh, do you have any question, please? If you do, you can ask. All right. Okay, so general design consideration, there are a number of characteristics which should be considered when designing an element or the entire design. Here are some of the important characteristics which we need to note. One, strength. Strength, okay, the strength of the thing that is being designed. Stiffness and rigidity is important. Wear, corrosion, safety, reliability, friction, okay, usability. We have utility, cost, processing, the weight of it, the life of it, the noise that thing will make. All right, we know that noise may not be desirable, and we want it to operate with the noise level to be as low as possible. The styling of it, its aesthetics, the shape, how it looks, the shape, the size of it, right? Is something small and portable but powerful, or huge? We need to look at that aspect. Control, thermal properties, surface finish, lubrication, marketability, maintenance, volume, liability, and then we have recovery. So these are the some of the important characteristics of the machine that we need to consider as we design. All right. Okay, so we go to the requirement of a good design. The requirement of a good design.
Question.
Design must be okay. Go ahead.
During designing, how do we factor in fatigue in our process of designing so as to, in a way, avoid failure?
Fatigue. Well, we have what you call a fatigue analysis. Okay, that is determined at the analysis stage where you are doing design and doing some analysis. Okay, so at that stage, when we have done the design, where you are using engineering formulas to be able to size the component and all that, you need to look at the forces, okay, that will be in play when that particular machine element is working. All right. So if you have it loaded in a way that you know that there will be fatigue loading, that is where there will be a cyclic loading. Right? Cyclic loading is like there is repeated to and fro. Okay, so if for instance it's like you are hammering, let's say you have a big hammer and you are hammering a wall. All right, so you see that at impact, when you throw the hammer against the wall, it impacts the wall. At that point, there is high level of stress that is developed. Okay, then after hammering the wall, you release it, which means that like you take the hammer away. When you take the hammer away, that force is released. Okay, then it comes back again. When it comes back again, there is another force. So it's like the force is repeating itself and it's intermittent. All right. So it's repeating intermittently, and that causes fatigue in the system. And in design, there are certain things that you could do to relieve those fatigue stresses that may develop, right? So it all depends on what we are doing. When we have done the design, there are certain points on the design that you will call stress concentration. And when a design is to fail, it's likely to fail at that point. And that is where the analysis comes in. And now we have software that can be used to do that. Before, you know, have you done strength of materials?
Yes, the strength one.
Strength one, you know about bending moment, you know those things. Shear stress, shear force, bending moment, and you
Yes,
have
sir.
done something on stresses, okay? Now, the essence of the bending moment, you see that when a load, a particular member is under the application of some load, okay, that member is prone to fail at some point along it, and is likely to fail at the point where the bending moment is highest, okay? And so in design, that point where the bending moment is highest, we consider that point as a stress concentration point. And therefore, special attention has to be paid to that point in order to prevent that part from failing at that point. Okay, if it's having, let's say, a sharp neck, okay, maybe you have something like a cantilever beam. All right, that cantilever beam, one side is free and the other side is matched to a wall. At the neck, where the bending moment is going to be very large, you know, that's likely to fail there. So at times we provide what we call stress relief, which maybe they will provide something like a fillet at the joint where it's merging with whichever member that is merging with, so that though there will be built up of stress there, it will not be prone to fatigue failure due to that fillet that is provided to relieve that stress. So it all depends on what that part is going to be used for, that machine is going to be used for. If you know that there will be cyclic loading, there will be fatigue loading, then you need to be able to design it against that. And also, we determine that by using engineering calculations and softwares. That is where that stage comes in. Because for instance, there are some software that you can use. If you have your drawings done and everything, you can do analysis on it, like finite element analysis, and it will be able to give you the weak point on the material and where the material will fail. You'll be able to determine that from that preliminary stage before you even go ahead to manufacture. So usually when that is determined, modification is done to try to prevent that from happening before production is done. Are you okay?
Yes, sir. So, one last thing, please. What softwares do we use for those simulations? And
Oh, there are many of them. There are different finite element analysis software. There is something like you can use ANSYS to do it. There is Autodesk Navstar, which can also be used for that. And then there is one called KCR. Even SolidWorks, you can do some analysis in it. There are different software. It all depends on the one that we think you'll be comfortable with. Yeah. I hope you're okay.
yes, sir.
Thank you.
See you on that.
All right, so we have the requirement of a. Oh, our time is up. Okay, let's look at this last one before we end. The requirement of a good design. A design must be, one, functional. All right, you should fill a need or a customer expectation. It should be able to work as expected. Okay, it should be safe. The design should be safe. It should not be hazardous or to the user. All right, or it shouldn't be something that can harm those who are standing by. And it should be reliable. It's something that we can depend on, and it will work. It will not disappoint people that when they're using, all of a sudden it fails. No, it should be reliable, and it should be competitive. All right, there may be other similar designs in the market, but this one that you want to produce should be able to stand out and compete with the existing ones on the market. And the next one is usable, to be able to accommodate human size and strength. Okay, and then the manufacturable, having minimal number of parts and suitable for production. And then also marketable, it should be a product capable of being sold and serviced. Okay, so the product should be able to sell well, and there should be something that can be manufactured, and it's something that is usable, competitive, and the other ones. All right, thank you very much. We'll end here. So God willing, when we meet again, we'll go to the next stage. I'll try to do some video recording and post it on the next one so we can move quickly. All right, thank you. In the absence of any further question, we'll end here. God bless you. And,
so we need the
so please, how do we get the lecture material?
I forwarded to your class rep, so I'm giving only the hard copy. So he will print them. You can contact him for your copy.
Okay, sir.
Thank you.